Hello, this is Professor White. Today we will look at arithmetic series and series notation to start with. So, let's get started. I will look at the series notation and then actually calculate a sum for a series. And there is something called mean of sequences, and we'll look at that. But particularly, I will also look at arithmetic series and find the number n for a given series. Let's say they give you the sum, and then you don't know how many numbers you added. Okay? So let's get started. What is a series? There are two kinds of series, finite and infinite, just like for sequences. A finite series is you're adding a bunch of numbers. It's the sum of a finite sequence. So you need to go and watch to understand this video, you need to watch the sequence version of it first. An infinite series, it is sum of infinite sequence. Okay, and this is how you show it. You have the sum, you start with 1, and for example you end with 5, and you have inside the sum notation you have a formula in terms of I. What that means is you take I equals 1 and you add to it I equals 2, then you add to it I equals 3, then you add to it I equals 4, then you add to it I equals 5, and you stop. Okay, so when I is 1, 1 square. When I is 2, 2 square. When I is 3, 3 square. When I is 4, 4 square. When I is 5, 5 square. So you just go ahead and add all these numbers together and you'll find the series. Okay. Now, let's go do some more complex cases. Let's say I'm adding from 2 to 5, and my formula is -1 to the ith power times 2 times I. And you can actually write what those are. You're going to start with I equals 2, and you're going to add I equals 3. Then you're going to add I equals 4, and you're going to add I equals 5. So it does not have to start from I equals 1. When you put this in there, you're going to get -1, since the first power is 2, and now you're going to go 2 times 2. The next one, this is going to give you 4. The next one is going to be -1 to the third power, and it's going to be 2 times 3. That's going to give you -6. The next one is going to be -1 to the fourth power, 2 times 4. That will give me +8. And the next one, -1 to the fifth times 2 times 5, and that's going to give me -10. And when you add those up, you're going to get -4. So you can do one at a time and add those up. So that's fairly easy. Or they may give you a sum. They may say, well, can you give me the general formula, that sum notation? So how about we have something like this. 1 plus 4 plus 9 plus 16 plus 25. What are you doing? You can do the same thing with this. 1, 4, 9, 16, 25. And this one is you're getting, this is when your index is 1, your index is 2, 3, 4, 5. And you can see the relationship. So I can write this 1, 2, 3, 4, 5. So that means I am adding from 1 to 5. What am I adding? I'm simply adding I squares. Or you can have an alternating one. Let's look at given. Here's another example. 1, -1/2, plus 1/4, negative 1/8, plus 1/16, and you can see, okay, this is 1, this is 2, this is 3, this is 4, and so forth. So that means I have 2, this is 3, this looks like 2 to the something, but the problem is I have, like, when it's 1, it is 1, when it's 2, it's negative. So you have this situation, negative 1, for example, I plus 1, I minus 1, it doesn't matter. If you write it like this, and then let's say they put dot, 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 that means you go all the way to infinity. It's an infinite series. And now what else do you have in there? You have 1/2, you're multiplying by that, and each time it's 1 less. And you can probably write it like this, I equals 1 to infinity, and you have negative 1/2, and then to the I minus 1. Okay, so the best thing to do when they are giving you a list and you're trying to come up with something, just tabulate it and try to find the relationship. Now let's look at a particular series where you're adding an arithmetic sequence. Remember, let's say we are talking about an arithmetic series then. And what was the deal with the arithmetic sequences? In arithmetic series, that means you're adding n terms. The first one was a1. The second one was a1 plus d. And what was the third one? a1 plus 2d. What was the fourth one? And you go all the way to a1 plus n minus 1d. If you watched the previous video with the sequences, you'll see that. Now what I'm going to do, I'm going to write Sn again, but this time I'm going to write it the other way around. So this way, from right to left. This is your last term, remember? So that means An. And the one that's right before the last term is going to be last term minus d. Remember? And then the last term minus 2d, and so forth. And at the end, you're going to be all the way down to a1. Does that make sense? All right. Now, when you look at this and you add this up, what you're going to see, 2Sn, 2 of these guys, and then things are going to kind of cancel out. These two will cancel out. What are you going to end up with? You're always going to end up with a1 plus an. But how many of them in these couples? 1, 2, 3, all the way to n. So you're going to have 2Sn equals a1 plus an over 2. Times 2. So Sn is n over 2 a1 plus an for an arithmetic sequence. All right? So this is pretty easy. So if I know a sequence is arithmetic, sometimes they call this a bar, which indicates a mean, and they say, okay, well, use this a1 plus an over 2 as your a bar. So you can write your arithmetic sequence as n times a bar. Okay, let's do the mean of the sequences for an arithmetic and non-arithmetic sequence. For example, let's look at some like this. Let's say I'm looking for 2, 4, 6, 8, all the way to 16. One way to find the mean of that sequence is going to be add them all up and divide by however many things that you are doing. But since I know this is an arithmetic sequence with the d of 2, so each time you're adding 2, all I have to do is take the first term, which is 2, take the last term, which is 16, divide by 2. 18 divided by 2, that will simply give you the 9, which is the mean of your arithmetic sequence. Or another problem might be, they give you a bunch of things and they may say, okay, find the SN, the sum. Okay, well, let's say I have something like that. 36 plus 41 plus 46. What am I doing? This one is always 5, right? So my D is 5. Okay? And I go all the way to plus 91. So what does that mean? My A1 is 36. I don't, need anything else. And my AN, the last one, is simply 91. And I also know D is 5. So let's put in the formula. 91, I don't know how many terms, but I can figure it out. 91 is going to be the first term plus n minus 1 times D. Okay, I do know the D, so 91 equals 36 plus n minus 1 times 5. Can I solve for n? Absolutely. That will give me n of 12. So when they are asking for that, they're asking what is the sum of your first 12 terms. So I can just put that in the formula. What was the formula? It's the first term, which is 36, the last term, which is 91, divided by 2, times the number of terms. And I figured out the number of terms. It's just simply 12. And then I can just plug it in, and I get 762. So it is very, very handy, and that's all there is to it. You just have to figure out how many terms you added, and you have to figure out the D, which is the difference. It can be positive or negative.